Hello everyone, welcome back to the Green Chemistry Education webinar series hosted by the Green Chemistry Commitment and Beyond Benign. My name is Amy Cannon. I'm the Executive Director of Beyond Benign, which is a nonprofit dedicated to green chemistry education in K-12 to higher ed. This webinar series is designed to highlight relevant topics in green chemistry education for faculty and students who are looking to adopt green chemistry in their courses and programs. Just as a reminder, for those of you who are tuning in again, and for those newcomers, we're broadcasting live and recording this session. So all attendees are in listen-only mode and all lines are muted. So if you have a question, just feel free to type it right in there into that question chat box on your control panel, and we will get to the questions right at the end of the presentations. We'll respond to as many as we can. The recording will be posted on the link that you see and also that you see in the welcome box and on this slide. And any supporting documents, such as the presentation slides, will also be posted on that link as well. For those of you who participate in social media, please connect with us on Twitter or Facebook. We'd love to hear some live tweeting going on if you are so inclined. And please also let us know if you are a class or a group tuning in from a college or university. We would love to give you a shout out. We love it when groups are able to join. This webinar is being brought to you as part of the Green Chemistry Commitment Program, which is a consortium program aimed at transforming green chemistry or chemistry education, expanding the community of green chemistry practitioners, growing departmental resources for those looking to adopt green chemistry, and improving connections to industry. The program is voluntary and flexible, and it's for adopting green chemistry student learning objectives and for promoting the work that you're currently doing at your institution that can serve as models for other institutions to get involved. You can find more information right on our website, or feel free to email me directly with more information. And as always, as part of our webinar series, we give away a green chemistry resource or book at the conclusion of each webinar. We randomly select a participant from our list of participants, and if you are a winner, you'll receive an email immediately following the webinar and with more information. We'll contact you right after. All right, so we are very happy to launch the first webinar of this academic year with two speakers that I know very well personally here, Kate Anderson and Mollie Enright. I'll introduce them to you briefly, and then I'll hand the controls over to them for their presentation. And again, feel free to type in any questions at any point during the presentation. So Kate Anderson has been with us here at Beyond Benign since almost the beginning, since 2009, and she currently leads our K-12 programs, which you're going to hear more about in this presentation. She has a background in environmental education, having received a master's in education curriculum and instruction with an emphasis on environmental education from Florida Atlantic University. And Mollie Enright is our K-12 and outreach program manager here at Beyond Benign, has been working with us for the past 2 years, helping Kate in K-12 in the K-12 and community engagement programs. And she has a bachelor's degree in chemistry from Gordon College, one of our favorite partner institutions. So these two are passionate about green chemistry education, and I'm so fortunate to have them on our team here at Beyond Benign. And again, I'm happy to have them kick off this webinar series and provide us some examples of our freely available open access resources for K-12 and outreach programs. So with that, I'm going to hand the controls over to you guys for the presentation.
All right.
Looks great.
Fabulous. Thank you so much, Amy. And this is Kate Anderson.
This is Mollie Enright.
And we are delighted to be with you for presenting K-12 outreach and education, engaging students through green chemistry innovations. All right, so here at Beyond Benign, we are a nonprofit dedicated to green chemistry education. We were founded in 2007 by both Dr. Amy Cannon and Dr. John Warner, and we are located just north of Boston in Wilmington, Massachusetts. So as you can see our mission and vision there, we are an organization that is all about trying to promote green chemistry and, basically make it so that when everyone's learning about chemistry from basically the very, very beginning all the way through in industry, that they're learning about it through the lens of green chemistry. So that's a little about us as an organization. All right. So the work that we do primarily consists of 3 programs. We work in K-12 curriculum training. We also work within the community engagement and higher education. So you've heard a little bit about our higher education program and the green chemistry commitment. And again, for more information about that, you want to stay tuned to more webinar series. Be sure to be connecting with Amy and make sure that you're on our mailing list for that. Our K-12 programming, so this is where we develop curriculum, we do professional development trainings, and we do all of this under essentially the guise of our lead teacher program, which we are now in our 2nd year. But as an organization, we've been working with teachers since the very beginning, you know, and really we pride ourselves in being an organization for teachers and by teachers. So that's how we do our curriculum, and that's how we also develop and do our teacher trainings, so that it's actually teachers leading other teachers. And right now we have 15 lead teachers from across the country that are helping us to get out and spread the word and be, you know, green chemistry ambassadors across the US and Canada, which is really exciting. Now, community engagement, this is primarily what we're going to focus and talk about for this webinar, and we're going to talk about our College Student Outreach Fellows program. And this is the program that helps bridge the gap between both our K-12 programming and higher education programming. So I'm going to turn it over to Molly and have her talk a little bit more about the Outreach Fellows program.
And so our community engagement program really does kind of heavily emphasize this College Student Outreach Fellows program. And as an organization, it's kind of that question of why do we spend so much of our time, energy, and resources into doing community engagement? And I think most people that have tuned on here will probably all agree with us that community engagement matters. It makes a difference to be out there sharing our passion for science with young people, with people outside the sciences. But how can we really kind of affirm that, especially as a nonprofit that is really relying on support from our partners to be able to do community engagement and support our fellows? And so a study came out from the University of Chicago back in January that it really affirms that just talking to young people about STEM careers makes a big difference. It increases their test scores, and it also increases their interest in careers in STEM. And so if you're not part of the education world, you're not familiar with that word STEM, we're really talking about science, technology, engineering, and mathematics as kind of a really broad way of categorizing those careers. And as a science education nonprofit focusing on green chemistry, that's really where we really fit into that STEM world. It also really helps us support our community partners. And so we work with a lot of groups, both on the North Shore of Massachusetts, as well as in the Boston area, on a very local level. And so we have some groups that we work with that are doing amazing things for the students that they serve, but they may not have the best resources or the best setup to be doing more of the hands-on, in-depth science engagement. So for like Girls Inc., they are doing such great things. We work with Girls Inc. of Lynn, Massachusetts, but we can really help support their efforts to show girls careers in STEM by sending volunteers to work with them, by letting them use our outreach materials, by sharing free resources with them so they can then do their mission better. And the piece that I think all of us are really familiar with, that's a little bit less tangible, is just community engagement. Working with young people can empower the next generation of problem solvers. And in green chemistry, that's what we're really excited about. We're excited about all of the ways that green chemistry can be a way to solve really big problems in our environment, in our world. And this is where we really know that community engagement matters. It's a little bit more hard to report on that. We had a lot of smiles, but when you are out there actually engaging with young people, engaging with students, and just seeing them discover something for the first time, or seeing them get really excited about a question that they need to know the answer to, this is what keeps us going back to community engagement and gets our volunteers so excited to keep doing this with us. And so college students, why do we choose college students as our force for community engagement? And I think many of you tuning in may also be in this category. You are an undergraduate and you want to do community engagement. And so we see college students, we see you as huge change makers. You're flexible. College students have a really flexible schedule compared to the rest of us. And they're also learning about a lot of the opportunities in the sciences for the first time. They're getting excited about their classes. They're seeing all of these ways that they have the potential to change the world, and it can just overflow really easily into community engagement, that they're just sharing their passions. And that flexible schedule really allows them to be the ones that are out there on the front lines at these different community events. So our Outreach Fellows program, just to give you a quick overview of what that looks like for us. So we have students that we work with primarily from local universities. We're based in Massachusetts, so we have schools in the North Shore, the greater Boston area, as well as 2 schools in Maine that we work with. And so we train these students in green chemistry and outreach in primarily how do we communicate these really high-level concepts in chemistry and sustainability to really general audiences, so elementary school kids as well as the parents of elementary school kids. We ask for the full academic year commitment, so that's 2 semesters, starting in the fall, ending in the spring. And we ask that they participate in a minimum of 4 community events. So these events might range from National Chemistry Week at the Museum of Science in Boston, all the way to our local elementary school, middle school STEM nights hosted by the community. And we also do give our student fellows the opportunity to apply for kind of a bigger event with us to be our ambassadors there. So on a rotating basis, it'll either be the Green Chemistry and Engineering Conference hosted by the American Chemical Society's Green Chemistry Institute, or the USA Science and Engineering Festival, which is in Washington, D.C. every other year. And so I'm going to hand it back over to Kate to talk about some of our activities.
Thank you. Terrific, Molly. And yes, college students obviously are overflowing with enthusiasm and passion, which always translates really well for young people. And so one of the activities that we do typically as an introduction to many of our other activities is a pretty simple matching game, but it does open the idea and gets people thinking creatively. So we like to ask the question, how can we learn from nature? So what is it that we can do to learn from nature? Now we have developed, we've got 2 biomimicry matching games. We have an introduction one, which I'm going to go through just a couple of the examples with you in a minute, and then we also have an advanced biomimicry matching game, both of which can be found on our website and are easily accessible and made for you to be able to download and use and make them your own. So if you're doing this in a classroom setting, then usually we set it up where you have a few of these sets of cards that you pass around and have students work in teams of 2 to 4, and we ask them to first define what is biomimicry, break the word apart, bio and mimic, So once you have the students actually giving you the answers, because this is a theme throughout a lot of our outreach and engagement, is that we are engaging the students. So we try to limit our talking at them and actually make it so that it's more of a conversation and a dialogue, and that you're building off of prior knowledge of the students that you're working with, whether it's at a tabling event or in a classroom. So once we've set the stage, we've figured out, okay, we've identified what biomimicry means, so now let's play this game. So the challenge is for students to match the technology with either plant or animal and figure out how and why nature inspired that technology. Was it the form, function, what is it about that? So we're gonna walk through just a couple right now. So termite mounds. What comes to mind when you think about termite mounds? They're pretty amazing structures. So if you think about in the desert, they can grow to be 5-6 feet tall. And the termites that are in there, they have a pretty wonderfully climate controlled environment that they live in. And why and how is that? So, and how could this actually inspire us to create structures that perhaps don't need electricity? So for this match, it's electricity-free buildings and the termite mounds. So this, again, there's a form and a function that's very, very specifically aligned here, and the students can start to see this and then you ask them to explain the why, all right? So the way that we're doing it is not how I would do it with the students. I would ask the students to explain to me how they've come up and derived the match. And you'll get some really creative ideas. So part of having this conversation and dialogue is to talk about that biomimicry is about ideas, and maybe they didn't come up with the exact match that we set up in the game. That's okay. We want students to feel as though they can be inspirations and think creatively. So you really want to challenge them to think creatively. So here's another one, mussels. What are some things that you know about blue mussels? And when we go around, especially in a classroom setting, asking the students, what do you know about them? What do you notice in this picture? What are they doing? Oh, they're sticking to something. Okay, so one of the matches, one of the opportunities from the match is glue. Wow, how about that? So blue mussels have inspired a soy-based adhesive coming out of, and this was actually a Presidential Green Chemistry Challenge Award. So for those of you who are who have been learning about green chemistry at your schools, maybe this is an example that you may have already heard about. So this is a great one that links back not only to our outreach materials, but we also have an entire lesson plan all about biomimicry and adhesives. So there's a lot, there's a lot more that you can expand on with this particular one. So this is kind of a nice one to link back again, because it's the chemistry. It's looking at the proteins of the bicycle threads and how they're able to adhere underwater. And this is how, the Columbia Forest Wood products, how they were able to actually derive this soy-based adhesive based on those protein threads. And last but not least, we're going to look at it from a different angle now. So submarines. Okay, what do we know about submarines? Yes, they're underwater. All right, let's expand on that. Now, how could we design them better? What if this submarine in particular was not really as fast as we wanted it to be? Are there animals, are there creatures that we could look at that actually are really, really fast underwater? Now, sharks. Okay, this one students go wild about, and they get really excited, and they see it's really clear. This is a clear match that I will say 9 times out of 10, this is the one that they match most confidently and first. So you build off of that initial knowledge, and then you press them to open up the doors to ones that they will not be familiar with. But yes, so we've got our clear match of the shark and the submarines. So when wrapping this game up, and again, for each set, you have, I believe there's 8 matches in each set, and that helps, just have an internal dialogue. And again, depending on if you're doing this at a table, you're only going to want to do a couple of matches because the students will come for just a short period of time. But if you have this with a classroom setting, this helps to really set the groundwork for, okay, now we've learned a little bit about biomimicry, and through those matches, we started to think about how it inspires products, how it inspires these technologies. And products and processes, that's where green chemistry, right? It's all about the designing of products and processes. So for students to understand and connect and see that nature already has been doing things pretty amazingly. If you look at, an ecosystem, then we're already thinking about how to do things in a more energy efficient manner. We're already handling waste in a really fantastic, we're not creating hazardous waste sites in natural ecosystems. So what are the things we can learn from nature that could better lend, ourselves to better development of products and processes? So you'll see here that, it's all about, biomimicry is all about ideas, and innovation can come, but you'll see that you could have an example of a product that derived from nature, but doesn't consider the solvents that it's using, and doesn't consider, the end of life. It could end up that it has to go into hazardous waste. Now, that's not taking green chemistry principles into effect if we're still coming out with a product that has those end results. So this helps to just get students in line with thinking, okay, how can they work together in synergy, and also how they are different. So now we're going to talk about a really cool example that is biomimicry inspired. Go ahead, Mollie.
Thanks, Kate. And so I really like this next activity because it fits so well with biomimicry, and it really does cater to what the students already know and are already excited about. And so I always start with the question, what do you know about sharks? And so if we if we just did the biomimicry matching game for the elementary set, we would have already looked at the submarine. And so they would know about sharks being really good swimmers. And so maybe they'll tell me that sharks have a lot of teeth. Maybe they'll tell me that sharks have fins and are really efficient swimmers. Other times, students will tell me that sharks can never stop swimming or else they die. I hear that's a thing. I'm not a marine biologist, so I keep just affirming the students of, oh, wow, that's so cool. I didn't know that. Because it's so great to keep affirming that they're affirming their excitement, affirming their knowledge. But I want to talk to them about a biomimicry technology based off of sharks called Sharklet film. And to get to really what that innovation is doing, I ask another question of, have you ever seen anything stick to sharks? And so I had them think about that for a second. They look a little puzzled, and so I asked them again, well, what about whales? And so when you think about whales, a lot of stuff sticks to whales. You see barnacles stuck to whales, but do you ever see things stuck to sharks? And if they think about it, they're going to say, no, I don't really see things that stick to sharks. And the reason for that, which I get to unpack with the students, is that sharks have these really unique scales called denticles. So if we actually look at shark skin underneath the microscope at about the micron level, we're going to see these really unique diamond-shaped ridged scales called denticles made of cartilage that prevent things from sticking to it. So barnacles can't stick. We can't see anything stuck to sharks. But what's really interesting is that bacteria can't stick as well. And so a group of scientists got together. We're thinking about this, thinking about all of the problems related to how we control bacteria now, and thought, well, maybe there's something to that. Maybe we can use inspiration from that shark of how they don't let bacteria stick to them and use that for our own world. And that's how they got this innovation called Sharklet film. And so if we look at the Sharklet surface technology on the left, that's at the 20 micron level, you'll see that it's the Sharklet film, this is actually of a clear adhesive film that can go and be stuck to the surfaces of desks, hospital devices, cell phone cases, really areas where problem bacteria is going to accumulate, and using a lot of chemical sprays or antibiotics will be a problem. And so the Sharklet film looks really, really similar to the shark skin, the shark denticles, and that's where that inspiration comes in. And so it's actually using the same physical mechanism as the shark skin to prevent bacteria from growing. And so in our activity, we talk about this really briefly. We get students thinking about it, but then we want to show them the film, and then we want to show them how it works. So we actually have it set up in our classroom. So we're going to transition to a live video now so we can show you how it works. Give us a quick second. We're transitioning, turning our computer to show the live camera. Camera button, right? There we go. Okay. Hello, everyone. And so with the students at the table, we have a piece of Sharklet film with us. So we give it to them, we ask them to hold it, touch it, see, can you feel anything? Do you see anything? What are your thoughts? And so just looking at it, which you might not be able to see on screen, sorry, there's really no texture to it. It's just a kind of a smooth piece of clear plastic. Sorry. Are you seeing my video?
Sorry.
I'm there. Great. Okay. Sorry. Technical moment.
Sorry.
And so when we shine a laser pointer through it, that is when we can actually see that pattern. So if you can see on the wall behind me, it has a really, really unique diamond pattern that's etched onto that plastic at the micro scale level. And so for students, that's really exciting because now you're able to show them something that they can't see with their naked eye, and it's really exciting. And laser pointers in general are just very exciting too. But we want to get to this idea of how does it work? And that's where we have our Sharklet model. So we build a model using, right here is like sticky gems from the craft store with the dazzling, and we can also use puffy paint like for fabrics. And so we build a model of that diamond pattern that students can interact with. I have them touch it. Most of them are really excited. Oh, I want to feel it. And so then we can ask the question, well, how does it work? How do you think it works? And to simulate the way that the Sharklet film is working, is using Post-it notes and binder clips. So we put our Post-it note right over the Sharklet surface. We're comparing the stickability. I haven't come up with a better word than stickability, but I feel like it gets the point across. So we put the Post-it right on top of the Sharklet film pattern, and then one on a flat surface. And we use our binder clips to simulate bacteria adhering and accumulating on a surface. So to do that, we will just kind of clip them right on the Post-it. But first I want to ask the students, well, how many do you think are going to stick? How many binder clips do you think we can get onto this Post-it before it falls off, before it fails? And so depending on the students, we'll get any number of ranges of answers. And so then I will ask the students, well, why don't you help me? Let's test it. And so we'll put on, we have one. This is on the Sharklet pattern. And so it's going to depend on kind of the humidity in the room. If you're outside on a really humid, sunny day, it might be a little bit different. We're in a dry classroom, so it's going to be a little bit more binder clips. So we're up to 5. This will be 6. We got 7, 8, 9, 10. All right, and so as we're going, I'm going to have the students also guess milestones too. So we've reached 10. Okay, well, what about you? What's your next guess? Do we have more than 10? And so I will say, because it's dry in here, we're getting a lot more binder clips on here than we normally would. And so we're up to about 13, I guess. 14. There we go. All right, so this one on the Sharklet pattern is holding about 13 binder clips. And so then I have them move over and we guess again. So, okay, so that was with the Sharklet pattern. Reminder, what does the Sharklet pattern supposed to do? It's supposed to make things not stick. And so how many binder clips do you think we'll get on the flat surface without the pattern? And so I'm not going to do this on camera because it's going to take a long, long time. And normally we don't even get to the answer at the table, because if we did, this is what would happen. This is about 89 binder clips. Kate and I worked on this on Friday. And we actually, our pattern, our model was falling off the clipboard, and we had to actually hold it with 2 hands because of just how heavy this is. And so on average, you're going to get about, this is quite a lot for this. So on average, you'll get between 3 and 10. We got 13 today. And on average here, you'll get anywhere from 25 to 89. And so even when we have 13 binder clips on our Sharklet pattern, we can still really demonstrate that there's a huge, huge difference between having the Sharklet film pattern there and not having the Sharklet pattern, just having a flat surface, and how much can accumulate, how much can stick to that surface. So then really the big question is, well, why? Why is this happening? Why does this work the way it does? And that's where I'll ask the student. I want them to tell me. I don't want to tell them. I want them to discover it. So we can think about the pattern again. They can touch it, and it's bumpy. It's kind of a textured surface. So what does that mean? What does that imply? And a lot of them will figure it out, that it's surface area. There's just not enough surface area for the bacteria to adhere to on the Sharklet surface. And so they just can't grow there. They can't grab hold of it. Some students will need a little bit more of a guidance in that direction of getting to surface area, but most of them will be able to get it on their own. And depending on how much attention you still have of that student who's now been at your table for a little while or now been in your classroom, you can either end it there, or you can talk a little bit more about why does this matter. You really do want to kind of nail it in that green chemistry piece of, well, if we're using Sharklet film and we're in place of alcohol-based cleaners or in place of antibiotics, well, now we're not encouraging bacterial resistance. And so some of them will know what that means, some of them won't. But really kind of getting the green chemistry piece at the level that they're at is kind of our hope for this particular activity. And so that Sharklet, the film is not actually commercially available, but if you email us, we will happily send you a set of Sharklet film to do either in a classroom environment or at a tabling environment like this. And so with that, I'm going to turn it over to Kate, and she's going to talk to you a little bit more about one of our other outreach activities, which is also super fun.
Okay. Terrific. Thank you, Molly. Sharklet is a ton of fun. So, oops, there we go. All right. Now we're going to talk a little bit about an activity inspired from company Ecovative. So Ecovative is, and well, I'll talk a little bit more about that, but how do we introduce this? How do we get started talking with students? And again, we like to use questions to start our conversation. So we think about styrofoam, polystyrene. This is a pretty abundant product that's out there, you know, has lots of different uses. So we start there. We start with what do you know about styrofoam? You know, let's talk about the function. It has really, really good insulated properties. You know, what are the pros? What are some of the positives associated with styrofoam? So it keeps our food warm when we want it to. It keeps our coffee hot when, you know, when we get it from Dunkin' Donuts. You know, you can also keep your iced coffee cooler longer if you're using styrofoam. So it's got those insulative properties. Also, it's used a lot in packaging. So this helps open the door to conversation of, you know, some of the challenges. What are some of those challenges associated with polystyrene? And if you think about, you know, again, the students are going to be able to tell you, oh, that's something that while it can be recycled, isn't really recycled on a very good basis, because there aren't industrial systems set up to handle that. So what are some of the things that you would change about it? Because how long does styrofoam stick around in a landfill? We know that 500 to 1,000 years for a one-time use product probably could use a little help in the design area. And students get that immediately. So then, you know, I like to ask, what if we could grow your own packaging? And what on earth does that mean? And what does that look like? So to talk and to think a little bit more about this, if you're doing this in a classroom setting, one way to set it up is to actually have the students look at the life cycles of styrofoam versus Ecovative mushroom materials. And we'll talk more about how the mushroom materials are actually mycelium. It's the roots of mushrooms that then grow around agricultural waste that can take any shape or form. So if you think about these packaging materials, these are used for food. Our mushroom materials are not, but you can actually develop and mold these into whichever form you're looking for. So let's take a look at those life cycles. Now, when the students are doing this, they can easily see, and they'll sort. So they're given the two sets of cards all shuffled together, and their job is to sort and separate the life cycle of polystyrene and styrofoam and life cycle of the Ecovative mushroom materials. So for the styrofoam, you can clearly see that it's a linear life cycle. It's a linear system. We take our non-renewable resources and then it ends up in a landfill, typically. But what happens when we look at the Ecovative material and we think about the Ecovative material life cycle? So we're starting with a renewable resource. This is where it's actually grown. So that white that you can see in the picture of the natural growth cycle, that is the mycelium roots of the mushroom that are growing around that agricultural waste. And from there, it can be molded and formed into anything. So in this example, you can see the consumer product is a packaging material for a wine bottle. So wine bottles can be shipped using these mushroom materials. And then you'll see, okay, so instead of our minimal recycling, if we compare it to the styrofoam life cycle, now you have compost. And we've got agricultural production with compost. So if we think about this, and the students will always do a linear first, you know, when they're doing this life cycle matching game, basically. And so what we ask them to do then is to think, is there another way that the Ecovative material could be represented? A circle. So what we'll have them do is we actually have students come up to the front of the class and they will form themselves in a circle, which is really illustrative, you know? I mean, it really shows very clearly, and it's demonstrative so that the students can see, oh, right, now this is what a life cycle looks like. Here we have a closed loop because we're looking at a manufacturing process that has taken all of the pieces into account, and each one is lending, itself so that it's actually being used on that next step of the cycle. So it's definitely a different way of thinking about it, and the students appreciate and see, oh wow, this is a really a very unique and different way of thinking of a one-time use object that then again gets put back and becomes useful renewable feedstock for a new product. Now, in that last slide, basically I showed an image of the wine packaging. So packaging is just one of the uses for the ecovative material. It's also being used in particle board. You can find it in surfboards. It's being used, they're looking at ways to use it as insulation. So there's all these different ways. Also, if you go to the shop Ecovative Design, which is the link that we have here in the slides, you can find that you could actually get a lampshade. So they've done all sorts of creative uses with the types of material. And what we do when we're doing this as an outreach activity is we'll use an Ecovative Grow It Yourself kit. They send these out. It's really relatively inexpensive, $20 for a bag, which you can use for an entire classroom to make small molds. And when you're doing it in an outreach setting, it goes a long way. So when the students are making it, they're having a blast. They love getting their hands dirty, digging into the, basically embedded mycelium mixture. They mold it, and from there, they're able to put it into all different shapes. So we've had students who have actually done the soles of sneakers and made their own disposable flip-flops. We've had students who, there's lots of different material tests that students can do. They can do impact testing. You can do water resistance. That's a really fun one. Compare a piece of styrofoam to a piece of mushroom material, and does one of that, do they weigh more after they've been dunked in water? It's really, if they do a really good job on the growth, then the answer is you don't see a difference. I will say sometimes they can be impacted, but students enjoy creating their own extension projects off of this. So we've had students do insulative properties looking versus a styrofoam cup versus a mushroom material cup. They've done all sorts of different designs with these. In our middle school unit, they actually make their cell phone cases. So our whole entire middle school unit is all around a student investigation of them making their own cell phone cases using the mushroom materials. We even had one student who was recognized at the science fair after they had come and done outreach with us related to making their own mushroom material sample. So there's lots of different unique ways that it can be expanded. I will say that there is a growth period here. So it's a 5 to 7 day growth period in the best conditions, more like 7 to 10 in regular conditions. So if you see students in an after school setting and can see them week to week, this would be a fun one where you could set up and, kind of do it over a period of time. And then in that tabling environment, we have been able to do it as well. The students then are just left to be the ones who decide if they're going to do an impact test or what kind of material test they want to do, because the biodegradable, test is also something they can do as well. So now I'm going to turn it over to Molly, and she's going to talk a little more about one of our other activities.
So we're going to talk a little bit about our fabulous fabrics outreach activity. And so what's really fun about this one is you can really do a forensic science spin on this one. The key of it here is we want to have them identify an unknown sample of fabric. And so that's where you can kind of take it on that more crime scene spin if you want to do that, or you can just take it in a more general, we're going to do research today type spin. And the key to this activity is really comparing how different types of fabrics interact with dyes. And so we're using, we're introducing some main concepts here, like life cycle. Similar to Ecovative, we will start this activity out looking at 2 different life cycles. In this case, polyester and cotton, and compare those two. What they'll find is that they're not nearly as easy to compare as the Ecovative versus the polystyrene, and that fabrics become a really big discussion on pros and cons in terms of green chemistry. But it's good to get them thinking about it. And then really it's about properties of materials, introducing natural versus synthetic materials, as well as some fun with acids and bases. We're again using some pretty simple materials. So Educational Innovations has these fabric or multi-fiber ribbons you'll see on the left with the really sweet tie-dye lab coat, dyeing fabrics and seeing how different fabrics will absorb the same dye. And the dye that we're using is actually cherry Kool-Aid. That is, fun fact, one of the industry standards for testing stains. And so for our students, it's actually very, very industry relevant. And then we're using ammonia as well as some litmus paper. And so really the key of the activity, or the core of the activity, is we give the students an unknown sample of fabric. We know what type of fabric it is, they don't. And we give them that multi-fiber or multi-fabric ribbon that has 8 different types of fabric, one of which is their unknown. And so first we ask them if they can identify their unknown using just a magnifying glass, which is really, really hard. So most of them can't, or most of them will be really not confident in their guess. And then we start to talk about what are some of the really important properties about fabrics in our world. And we really try to lead them into this idea that dyeing fabrics is really important. We really care about color, and we're going to use that property to help us identify that unknown piece of fabric. So we'll do that. We'll dye our fabrics in the cherry Kool-Aid, and then the students are much more able to identify their unknown. And then we'll take it one step further and do some acid-base dyeing. So we'll have them figure out, is Kool-Aid acidic or is it basic? We'll introduce pH if we need to, and then we'll use litmus paper to decide, have we already dyed our fabric in an acidic dye or a basic dye? They'll figure out that Kool-Aid is acidic, and then I ask them, well, what do we need to add in order to make it basic? If we want to know how our fabric will then dye in a basic and compare it to acidic dyed fabrics, I give them vinegar and I give them ammonia. Again, a litmus paper test will then identify, what do we need to add to switch Kool-Aid from acidic to basic? And then we can do that next level of a comparison. Because if you look on the left, you'll see that a couple of the fabrics are really similar when you're in the acid dye. And so doing the basic dye, you can actually do a little bit of a deeper dig, there we go, a deeper dig into some of the harder to identify fabrics. And if you want to extend on that, you can talk a little bit about properties of materials, and properties of those fabrics, of why certain ones are dyeing better in acidic or basic, looking at natural versus synthetic. And so with that, I'll hand it back over to Kate and talk about what to do about CO2.
All right, so this activity, students just love to use dry ice. And that, when I say students here, I mean young people and college students, of course. So this was an activity that was developed by some of our fellows team members. And they wanted to talk about the challenges associated with CO2. But since we're all about the green chemistry solutions, it was, all right, how are we going to talk about the solutions associated to the problems that have been created as a result of excess CO2, climate change, ocean acidification, all of these sort of more well-known problems. Let's take our own spin on this and actually talk about the solutions. So for what to do about CO2, basically we introduced carbon and we start to talk about carbon dioxide, and then we talk about pH. So similar to pH from fabulous fabrics, only for this one we actually use a pH. So we have the students, if you're doing this in a classroom setting, then you would have them take everyday items, and we have pictures of everyday items, and they chart it onto the pH scale. So, where does milk fall? Where does antacid fall? And that helps to have this conversation about acids and bases and pH balance, and how important pH balance is, not just within ourselves, but also within ecosystems. So this helps to introduce the conversation and start talking about, again, some of those challenges related to CO2. So when we're thinking about oceans, so there's this wonderful pH balance that exists. What happens when that is altered? And what are some of the impacts that are currently altering our ocean pH? So this starts that conversation, and then we have our ocean acidification lab that we talk about and do with the students. Again, we don't want to give away the answers. I'm giving away the answers a little bit here, but with students, you want to have them thinking, okay, let's make some predictions here. So if you're given basically a beaker of salt water and we use bromothiamyl blue as our indicator, so then the solution turns blue. So now that it's blue, what kind of, we ask the students to make a prediction. What's going to happen if we add CO2 to our ocean water? We know when we add CO2 to beverages, you get carbonated beverages, and we can talk a little bit about soda. So what's going to happen to our ocean water in this particular instance? So I have a short little video here to demonstrate. And again, this is great for a tabling activity because you can just plop a couple of dry ice cubes into some water, and then you get that instant sublimation, and students are drawn to your table. They want to know what you're doing. They want to be a part of it. So typically we'll set things up for them and then let them be the ones who actually squirt the CO2 into the water. So I'm going to play our short little video for you and talk you through what's happening. So we're adding our 5 drops of bromothiamyl blue. We get our nice blue solution to start. And we know that it's basic. We talk about that. You can actually take, you can do a litmus test. You can get the pH, starting pH. And then the students add the CO2. What happens when we add CO2 to our solution? And you'll see a really dramatic color change. And the students, the young people, they love it. They get really excited. They want to do it again. And you can do that. You can replicate this at the table. You can go ahead and add some more base to it and just keep doing this over and over again. So this is the important point to say, all right, so if we're altering and if all of our excess CO2 is causing challenges related to climate change, where we've got our ocean acidification problems, and talk a little bit about the impact that it's having on ecosystems, now is the time to talk about what are some of those green chemistry solutions that are happening, and what are some of the carbon capture technologies out there. What's being done to actually capture some of this excess CO2. So out of the University of York, there's some really interesting research happening, and they're looking at how to take seaweed and potato starch waste, and what can they do with that potato waste and seaweed to actually capture carbon. So this is a really neat thing to talk about, and with the students, they get really excited about this and go, oh my goodness, this is certainly something that they will not have heard about before. So you can actually do this with the items themselves at a table. So put out a couple of different items and have them think creatively. Maybe it's some packing tape, maybe it's some pencil shears. And then you also have potato and seaweed for them to choose from. They're not going to pick the seaweed and the potato because they most likely will not have heard of this stuff. Then what about carbon dioxide as a feedstock? What's being done? Where's the research heading? And what are the applications that actually currently exist? So again, out of University of York, they're looking at ways to actually create lithium batteries using carbon dioxide as a feedstock. And there's a company called Blue Planet that is actually taking and using carbon dioxide as a feedstock in the creation of concrete, which is really terrific since the concrete manufacturing produces quite a bit of excess CO2. So that being said, we're going to transition over and talk a little bit about where to find these resources. So I'm going to turn it back over to Molly.
And so this is the link to just our website. If you haven't been, it's pretty easy to navigate. If you have been in the past, it's brand new and redesigned. So we're excited to introduce it to you. So this is the homepage. Everything is sorted up on the top. So if you're interested in the Fellows program, you can go to Community Engagement, Student Fellows, and learn more about what we do there. But if you want the enrichment activities, the community engagement activities that we just showed, you want to go to Curriculum and then Middle School. And then it's going to load, take you to the General Middle School page, give you a little bit of introduction as to what all of those different units are, and you're really looking for those enrichment activities. So you click on that box with enrichment activities. It's going to load a page that's going to have all of those different activities. And so if we want to go and download any of them, like the What to Do About CO2, if you click on Download Lesson, it's going to take you to a landing page for that particular activity with a little description of it. But here's what you want. Here's all of those documents that you're going to want, that you'll need to do the activity. So pretty simple. pretty easy to navigate. And if you can't find anything, just email us. And so we'll go back to the webinar. And so this is a number we're really proud of. Since we started the Fellows Program in 2008, we've impacted over 24,000 community members, including students, their parents, as well as a bunch of other people that we have met along the way. So we're really grateful for the student fellows who have helped us out. We definitely could not have reached the same amount of people without their help. And so just a little bit more about college students as change makers. We know that they can be change makers in their community. That's what we just spent so much time talking about. But if they are going to be a change maker in their community, the community they're most a part of is their campus community, who they interact with on a day-to-day basis with both faculty as well as other students. And so this is our theory of change. This is on our website. You can find it on the About Us page. And we do believe that green chemistry in the K-12 world is kind of that foundation to how are we going to get this bigger picture of a sustainable human health in the environment. And you'll see that K-12 feeds right into higher ed, which feeds right into innovation, products, and then this greater picture of a sustainable world. And so our college ambassadors, the student fellows, they are bridging that gap between the K-12 world. They're learning a lot about that, or a lot about what they can do in green chemistry with us through the Fellows Program. But then they're taking that back to their own university. And in a lot of cases, that can make a really big difference at their school. And so by talking to faculty, many schools, many faculty have been introduced to green chemistry. And a lot of our undergrads in the Fellows Program are a part of what's called the Green Chemistry Commitment, which is what this webinar series is all about, hosted by the Green Chemistry Commitment. And so we have over 40 signers, and this is just a quick snapshot of who these schools are that are doing green chemistry in their undergraduate programming. And a lot of these schools are also doing green chemistry in their student chapters. And so there's a really big push right now to become green chemistry student chapters. And many of your chapters are probably already doing some type of community engagement activity or event. And so just by turning your green chemistry or your chemistry outreach activities into green chemistry outreach, that is one way that you can earn green chemistry status or count that event towards your 4 events needed for green chemistry status throughout the year. And so with that, we're glad that you signed on to join us today, and we'd love to answer any questions that you have for us. So that's it. Thank you.
Wonderful. Thank you so much, Kate and Molly. That was fantastic. And you answered one of the questions that already came in about can this activity be used to fulfill a requirement to become an ACS Green Chemistry Student Chapter. I feel like it was planted. So I think you just answered it. And so it sounds like it's a resounding yes, and that these could be activities that could be used for that. So fantastic.
Absolutely.
If there are any additional questions, please type them into your question box, the chat box right there on your control panel. I do have 2 others here for you, and I'll let you know if I get any others that come in. I have one that is, what is the response that you have seen from students in implementing some of these activities? And there's no indication of whether that's K-12 students' response or fellows, so feel free to answer it in either way.
All right, well, I can do the K-12 student response, and then Molly can do the college student response. How's that? So in terms of, again, K-12 students who are hearing about this, especially through the lens of college students, they get really jazzed, and they so want to learn more, especially from the perspective of learning more about this young person who's in front of them, you know? So it really helps for them to see a young person coming into their classroom or being at an event talking about how they're excited about science, and the students, you know, they connect with that. They say, oh, all right, I can be like that person. And that makes a big difference. So I will just say that students usually are over the moon about hearing about these technologies and innovations, and they really like doing the activities and just knowing that science is fun. You know, we like to kind of end things and just be like, did you learn something new? And usually it's a big yes. And did they have fun doing it? And again, we usually get another really big yes.
Yep, and from the fellows' perspective too, a lot of the students wouldn't have heard about these innovations within their own chemistry departments or within their environmental science club. I know that there's definitely students that are a part of our team that are not chemistry background. And so for them, it's really exciting to be exposed to a lot of different technologies that they wouldn't have seen in their program, and it kind of helps show them to what really can I do with my degree? What really can I do with my interest?
That's fantastic. And very briefly, I'm going to announce the winner of our green chemistry resource or book. Stephanie Taylor will be emailing you right after the webinar, so congratulations. Another question came in. Are there any restrictions on the use of these materials?
So all of our resources across the board on our website are open access under Creative Commons, so you can take them, download them. Some of our outreach talking points are in PDF, so you won't be able to change those, but they're meant to be adapted in whatever way.
Great. And one final question that I've got is, where is this curriculum being used, and how widespread is the use of these materials?
That is a great question, and I can say again, I think maybe we'll break this apart into two sections. So our K-12 materials, so our lessons and labs that are written there by teachers and for teachers, that we have seen that the adoption and use of those has been international. So I know that we've had teachers from Australia, we've actually done trainings there. We've had teachers from India. So the exposure level of where these materials have gone is pretty high. And in terms of implementation, we do have a lot of teachers. So it's close to, I think our number is close to 4,000 teachers that we've trained across the US and internationally. So there's a lot of teachers who are using these materials in their classroom with students directly. And our lead teacher program now is enabling us to grow those numbers in leaps and bounds and reach an even larger audience. So yeah, and in terms of the outreach materials, I will say that a lot of students in the, again, who have been a part of the Fellows Program have been exposed to this. And while we have presented at Green Chemistry and Engineering Conference in Washington, DC, over the series of many years now, so students have been exposed that way. But it's hard to say exactly how many and from where the students are actually doing outreach. Yeah.
Great. Okay, wonderful. Well, that concludes our webinar. That is perfect timing right here at the end of the hour. So thank you everyone for tuning in for this first webinar, and you can see the screen here. Please mark your calendars for the next webinar. If you do miss a webinar, you can always access the recordings in our new webinar archive along with the supporting documents, so feel free to access that on our webinars page right there on the screen. And yeah, we'll see you next time. Thank you again, Kate and Mollie.
Thank you.